Find the intervals where the function is increasing and the intervals where it is decreasing. So we need to use derivative. That means let's find the derivative of this function. So here derivative is, this is a quotient, so we need to use the quotient rule. On the bottom is squared. On the top, so it's like when you have f over g and you want to find the derivative, that f prime g minus g prime f over bottom is squared. So derivative of top is 1 times bottom minus derivative of bottom is also 1 times top. That is t minus 5 minus t all over t minus 5 squared. On the top, t minus 5 minus t and t cancel. So we have negative 5 over t minus 5 quantity squared. That's the derivative of the function. Now we set the derivative to find any critical numbers. Derivative equals 0. That means negative 5 over t minus 5 quantity squared equals 0. Now we need to solve for t. We can think 0 as 0 over 1 cross multiply. Okay, and that gives negative 5 times 1. Negative 5 equals, this time 0 is 0. So negative 5 equals 0, which is a false statement. Negative 5 equals 0. That's false. That means derivative is never 0. So there are no critical numbers from this side when the derivative is 0. Okay, if we look at the function itself, t over t minus 5, this function, what is the domain? Domain means all real numbers except that makes the bottom 0. So t equals 5. T equals 5 makes the bottom 0. So all reals except 5. So domain is, we can write all reals means negative infinity through 5. Okay, because the bottom becomes 5. And, or we can write union 5 through infinity. So 5 is not in the domain. Okay, 5 is not in the domain. This derivative is undefined at 5 as well, but that's not in the domain. So we have no critical numbers because derivative is never 0. So let's look at two intervals then. So the domain is here negative infinity through infinity, and there is 5 missing from the domain of the function, right? Because 5 is not in the domain, so we can just get rid of that. So there is a hole in the 5. That's what we saw. So 5. So we need to look at two intervals, negative infinity through 5 and 5 through infinity. Now we pick a representative from each interval and plug that into the first derivative. Okay, this is first derivative. I want to take, this is 5, right? So let's take 0, let's take 10. Plug in here. If I put 0 here, I mean t, not x. The independent variable is t. Okay, if I do that, plug in 0, 0 minus 5. Negative 5 squared is positive 5. Negative 5 over 5 squared, so it's going to be negative number. So I'm going to write negative. So the derivative is negative in this interval. That means the function is decreasing. Let's plug in t equals 10 here. 10 minus 5, 5 squared, positive, negative 5 over that, also negative. So the function is also decreasing there. So decreasing, so the function is decreasing on, okay, this is not in the domain, so we cannot say throughout. So negative infinity through 5 and 5 through positive infinity. And where is increasing? Increasing on nowhere. Okay, just empty set. Okay, that's the final